Number 47. A rectangular sheet of cardboard is to be used to make an open top box by cutting out equal-sized squares from each corner. If the dimensions of the box, or if the dimensions of the cardboard sheet are 36 inches by 48 inches, then the maximum volume possible of the open top box is how many cubic inches, the nearest whole number. So if we kind of visualize this box, well, I need to do that. So here's one side, here's the other. So this is just the cardboard sheet. And we'll say this is 36 inches, this is 48 inches. So pretty much what you're going to have to do is cut out corners. If you cut out these corners, and then you'll basically be able to fold it up on this side, if you can kind of visualize that. And so in the end, this part here, I'll try to make this as obvious as I can. This part would be this extended all the way here. So this part would be your base, and then each of these sides, right here, right here, right here, right here, these would be the vertical sides of your box. And so we just have to find what volume maximizes this. So let's see, it tells us that we're cutting out squares. So the first thing we know is that all of these lengths are the same. So we can express the volume of this box. So first of all, if you look at the base, the red part being the base, you can see that for this end, the 48-inch end, that length is going to be 48 minus 2 times whatever size square you cut out. And then same thing for the 36-inch side, it's just going to be 36 minus 2x for this length right here. And then for the height, well, you can kind of tell for the height, something like this length right here would be the height. If you imagine folding it upwards. And so your only other dimension that you're multiplying by is just x. And you want to take this, you want to maximize it. Okay? So the way we can do that is we take this expression, and if we take the derivative and set it equal to 0, that will tell us at what length will we have the maximum volume. So I go to my calculator, because this is a hairy derivative to do on your own. So I'm first going to define this function. So I do f of x equals x, and then make sure to put that times 36 minus 2x, 48 minus 2x. So click enter. So now anytime you want to find the volume given a certain part that you cut out, so say you want to cut out things that are 5 inches, you click f of 5, tells you the volume. So if we want to find the derivative, you go to menu, 4, 1, or even quicker, you can also do shift minus. It's a cool trick I learned. So d over dx, derivative of f of x, and it gives us this expression. So to find where the maximum is, you just take this expression and set it equal to 0. So we actually get two values here, but only one of these really makes sense. So the one that we're going to use the 6.788. And the one we don't use this 21.2, because imagine you were to actually cut out these squares. Look. So this side right here is only 36 inches. And so if we cut out two squares with sides of 21, you've gone more than the length of the rectangle. Like, you can't cut out two squares that are that length. So we have to use the 6.7. So now that we know that, we have this function store that will tell us the volume of the box given a certain size square. So I'm just going to do f of 6.788897. That should be more than enough decimal places. Do Control Enter, and then rounding to the nearest whole number, we get 5,240. And that's an answer. It looks like that's answer choice A. Alright, so if you have any questions from other tests, make sure to leave a comment, and I'll make a video with the solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.